What's up, Jamokes? Welcome to day, I think it's day 6, okay? So this is a group work packet, okay? It says at the top. My best advice to you guys, try this out on your own, okay? And it says group work. Remember, this class is mostly working with your partners. And I'm sure you guys miss each other, right? You haven't seen each other in a couple weeks. So my best advice to you guys would be, hey, maybe reach out, do a little FaceTime, do a little group chat, do a little Zoom chat, and go through this together. Okay? What I've taken the liberty of doing is I've written down an answer bank for 10 out of these 11 problems on the front. Answer bank for front. Okay, so this is just only on this page. So those are the answers in no particular order for the questions below right here. So if you want to write those down and have those as an idea, that'd be great. All right. For this picture, I'm personally not going to do it. Maybe I'll post answers later. But you guys really have to think about what you have, and then really think about the problem. Okay, think about the problems that you have here, especially in this picture. If you start looking at everything at once, you're going to get overwhelmed. But if you kind of think about a few things like, hey, in this picture, there's like triangles, right? There's external angles here. There's inscribed angles, right? There's central angles. If you just view it as one piece at a time, you guys will do really well on this full page. So again, this is your answer bank. These go for these problems. This one's a word, or not a word. This is an angle name, so this is not included, but everything else is included. So show your work. You guys will do great. Let me know if you do have questions. I may come back to this later, but there's this for you. Okay, let's go to the next page. To the back. Okay, here we go. So if you look at this page here, right? Okay, there's a couple questions that you guys should actually do pretty good on. Okay, like number 2, you guys got that. That's all you. Number 3, totally all you. And even number 5, I want you guys to do those. Okay. But number 4, I'm just gonna give you a quick hint on it. I'm not gonna give you the answer. I'm just gonna give you a quick hint. Look at that beautiful sunlight. Wow. Okay. A B C D E F is a regular hexagon, so it's inscribed inside the circle. Okay. So it wants you to find arc C E A. Okay. If you think about arc C E A, 3 letters, so this means this is a big guy. So C to E all the way to A. So I want you to find what that arc is, okay? That's a big arc. So here's my hint to you guys, okay? A hexagon has 6 sides and 6 points. So there's a point, 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 and there's a point, okay? If I want to find the degree of this arc, right, okay, the circle itself is split in 6 parts. 1, 2, 3, 4, 5, 6. Since it's a regular hexagon, which again, that means equilateral and equiangular. Everything about this hexagon is perfect, okay? That means it's going to split the circle into 6 equal parts. So this is 1, 2, 3, 4, 5, 6 equal arcs. Okay? So if a circle is 360 and there are 6 equal parts, that means that each part is 60 degrees. All right, 60, 60, 60, and 60. Okay? There are 6 of those equal parts. But what I want is 1, 2, 3, 4 of those parts. So that would all equal 240. So I hope that makes sense. So again, not impossible, but you could totally figure that out if you're kind of focusing on that. Okay? Beautiful. That's something that you guys should try out, but would be good to know. All right? Down below for 6 and 7. 7, again, you guys are rock stars. That's on you to do. Okay? If you have questions, just let me know. But 6 is a really good problem. Okay? So quad, oh my god, quad's plan, TBT. Okay? Quad is inscribed in the circle. So it's just bouncing all off the circle. Okay? With angle D, being 130 degrees. That is angle D. Okay? And then it says, what of this stuff is true? Well, holy crap. I don't know. What do we do here? This is a very hard problem because there are three unknowns, right? We only know one angle, and they're expecting us to see which one of these things is true. So my advice to you guys would be to look at what you have for sure. You know angle 130 here, right? If I extend that out to here and to here, okay, it's going to make this arc, right? This arc right here. Okay, so that arc, okay, remember, is that if this is an inscribed angle, this is going to be twice as big. So that whole arc is 260 degrees, okay? Which again, doesn't help me with anything, okay? But what it does help me out with is this. This angle made this part of the circle. But whatever this angle is across from it, this angle here, that, if it's shot out, makes the other part of the circle, the full other part that I don't know. Okay? Hopefully that makes sense. But those two angles complete this whole entire picture. Okay? What I do know is that if this part of the circle is 260, that means this whole other part of the circle has to be 100. Okay? Because 260 plus 100 is 360 full circle. So watch that. And if this arc is 100, that inscribed angle here that makes is 50. Okay? That's the only thing you know. So angle U is 50. Okay? Another fact to know, and this is actually this is the easiest way to go about it, is that these two angles in the situation are always sup. So if that's 130, that's 50. They add up to 180. This will make this work. So there's your clue for that one. Okay. And again, number 7, you guys should totally be able to get. All right. So let's go finally to the back, the bak. Okay. So up top. So what they want here, OA is 15. Angle AOB is 27 degrees. Okay, so look what they're actually asking for you here, okay, in these sector problems. They want the measure of AB, the arc, and then they want the length of AB. So let's talk about the distinction between those two. This bottom one is the arc length. So this is the longer problem of us kind of working through a fraction of the circumference. That's the arc length. The measure is just the degrees. That's the nice and easy type of problem, okay? So AB, if I want the measure of that, well, the central angle is 27, then this is 27 degrees. Okay, nice and simple, okay? But the length is the actual distance. That's if I measured it out. So the length of AB, that is using the arc length. So that's a fraction of the circumference is going to equal whatever the arc length is. Okay, so you have enough info for the fraction, for the circumference, and whatever you get there ends up equaling your answer. All right, and I'll leave that on you guys to do. You guys are rock stars. If you looked at any of the notes past couple days, that should totally be enough to help. Okay, for number 9, OB is 4. That's the radius. This is 45 degrees, and it wants the area of the sector. So if I basically just said, hey, how much square units is that slice of pizza? Well, if this is 45, the central angle is also 45. Okay, so remember, area of sector, that is a fraction of the total area, is going to get you area of sector. So again, you have enough info for the fraction, you have the info for the area, and whatever this equals will be your answer. Okay, again, any part of the notes would give you that. And there you go. Beautiful. Okay, for number 10 and 11, 10's really not that bad. Oh my god, this looks like a track. Sad. I'm very sad. I basically missed out on most of my track season, which makes me upset. So I'm not going to talk anymore. I'm kidding. I'm good. It'll be okay. Life's good. Okay. On that note, let's show a minion before, just to make me a little bit happy. Which minion should I grab today? Yeah, let's do this one. So I have Invisible Girl. We might as well be doing Fantastic Four. There's Invisible Girl. Look, she's invisible. That's cute. There was actually a movie called Invisible Man, and that's totally different. Okay, never mind. Take it back. Perimeter here. This is actually a nice problem to do. Perimeter just wants to measure the total distance around this shape, okay? Kind of like the track. So look what we have here. The area, the area is going to be the area of this whole thing, which we'll figure that out. But perimeter. To find the perimeter, we need to know all the outsides. Luckily, this is 35, so this is also 35. So we have most of it, okay? But a trick here, because don't get confused this. This 20 is from top to bottom. That's this. Okay, that's not part of the perimeter. Okay, the perimeter is going to include this curve and this curve. Okay, so for perimeter, okay, actually a pretty simple problem. We have 35 plus 35 already. Okay, but I also need to add in what this curve is and this curve is. All right. Well, luckily, those two curves, if I put them together, makes the outside of a full circle. So I'm going to actually add 2 pi r, aka a full circumference, to make the total perimeter. But the question is, what is the r? Well, the r is unknown to us, but we know that the diameter of this thing is 20, so the r is really 10. Okay, so my perimeter is 70 plus 20 pi. Okay, they're different units. This is normal numbers, this is with pi. So that's how you write your final answer for the perimeter. All right, so again, think about it in its full terms. Okay, area is a little different. So area, we could easily get the area of this rectangle. It's just base times height. So 35 times 20 is 700. So that's the inside. But I also need to add the area of this piece and this piece. Well, if you think about area, this and this make a full circle. So I'm going to add pi r squared to get the area of those two circle halves, which make a full circle. Well, the radius is still 10. Okay, so to add this together, that'd be 700 plus 100 pi. And there you go. That is your area total. Leave it like that. That's perfect. You can't put these together. Don't put 800 pi, otherwise I will die. Dramatic, but that's me. Okay. Finally, the last problem over here, number 11. I think that's the last. Yep, it's the last. Okay. So for the last problem here, here's what you got to think about. Okay. AB is 4. BC is 3. Okay. What you need to do here to find the shaded area is the same thing we've always done. We take the total picture and we subtract what we don't want. Okay? So the total picture is the big, massive, huge circle. Okay? That's the big circle. And we're going to subtract away the small circle. Okay? Well, if we're doing area, nice and easy, it's going to be pi r squared for this big one minus pi r squared for the small one. Okay, 2 different pi r squareds. So the idea is, of this big circle, what's the radius? The massive whole thing. Well, 4 plus 3 makes this inside 7. So this would be pi r squared. That's the massive big circle. Versus the small circle, which I'll color in pink, why not? If I want to get rid of that, the radius of that is just 4. Okay? So that's pi of 4 squared. So in the end, you have 49 pi minus 16 pi, which is 33 pi, is what's left over. Okay? Hopefully that makes sense. If not, sorry. Okay. Let's go back to the front real quick. Let's go back. Okay, hopefully at this point you have done this problem. Okay, I hope you guys have done that. Trying to think where I could start. Let's do this. I'll get you guys a little jump start on this problem. All right. You could start anywhere you want. Some of these things you can find by itself. Some of these things need to be found from using other things. Okay, but let's just do a little work here. Let's just see. Something I saw right off the bat is this. Angle 1. Okay? Angle 1 over here, if I extended this out to here and here, okay, it makes that arc. Okay? So if you want to just kind of just jump around and see what you know, this inscribed angle is always half of the arc it makes. So if this is 30, angle 1 is 15. So look at that. I found what angle 1 is. Okay? You could also, if you wanted to, go to number 2 here. This makes this arc. So as a central angle, if this is 160, so is angle 2. Okay? You could find that. Okay, that's a good start. There's a lot of other things you could do first if you wanted to. Like, hey, 4, a radius touching a tangent is going to be 90 degrees. It's going to be 90. Okay? Easy, right? Things that are easy, get them done with. Oh, look at this here. This is beautiful. Okay? Let's look at 5. Look at 5 over here. 5 shoots out this way and this way. Eek, that's not straight. And makes this arc.